So, friends, good morning and welcome to this lecture series of geomorphology. Today, we will discuss about the classification of mass wasting. If you remember our last class, we are talking something about mass wasting. What does it mean? So, mass wasting, there are two criteria has to be fulfilled. One is the rock must be weathered. Second thing, gravity plays major role as compared to other geomorphic agents like water and wind and glaciers, also these things. So, that means I want to say gravitational influence and weathering of material or removal of material from the intact rock body, and it is downward movement. It must be sure that it should be downward movement due to gravitational influence, that is defined as mass wasting. But that does not mean that water should not be there. Water is there, but it is playing a different role. However, the major role in mass wasting of the gravity. So, today we will classify the mass wasting. Why we should classify it? Because classification, as we know, it is for categorization, for easy understanding. Once we classify a mass wasting or anything we classify, we categorize it into certain boxes, and once we say that is of class this or class 1 or class 2, class 3, that means some perception comes in our mind. So, that means for example, suppose we classify it, this is of creep. So, creep, once we say something comes our mind that it should be slow process, it should be very gentle slope, it should take very long time. So, that is why once this classification comes in our mind or a class comes in our mind, we have to plan accordingly, because most of this mass wasting they occur in the hilly terrain, but plain areas are there which are recording this mass wasting, but it is of negligible. But most of these hilly terrains they are suffering mass wasting in different rates in different geological time. As present days, we are very eager our development programs, and due to these development programs, we are going to modify the hill slopes. We are constructing large dams, reservoirs, we are constructing roads, we are widening the roads, we are going for tunnelings. So, those developmental projects and SEZ. So, for this we have to modify our existing hill slopes. So, once we classify the types of mass wasting which is going on in that particular area, that means it will be easy to understand the nature of this mass wasting, so that the remedial measures we can take in that particular area will be specific. So, specific mass wasting scenario is, if it is there, we have to plan our developmental program accordingly, so that specific remedial measure has to be taken there. So, that is why mass wasting classification is must. And to before classification, it should become comes in our mind that it is a gravitationally triggered phenomena occurring up to down slope, and it is a slow process in certain cases, but in a rapid cases in certain cases. So, the structure it should be weathered and weakened rocks of mass. The primary process is gravitational instability, and time ranges from few seconds to few millennium years. So, that means though we say the mass wasting it is a slow process, but depending upon the process involved, depending upon the type of mass wasting, its time varies. Some of this mass wasting it takes millions of years to move a meter, and some of this mass wasting, even if 1 minute or 1 second, whole mountain front will be vanished. And mass wasting is a category of a transitional phenomena between this weathering and erosion. So, weathering, it creates material, erosion it removes in the help of flowing water, with help of wind, with help of a glacier. But once we say it is mass wasting, that means those removal of the slope material, it is due to the influence of gravity, that is mass wasting. So, mass wasting has been classified according to different parameters. What are these parameters? First, the parameter is the type of material involved in motion. Type of material, that is important. What is type of material? Once weathered material is there, the weathered material is there means we have boulders, we have cobbles, we have pebbles, we have clays like big blocks of rocks. So, what type of material is in motion? Either soil is in motion or soil water mixture is in motion, only soil debris is there, only rock debris is there, and size of the rock debris, if it is block size is there or it is small particles like pebbles, cobbles, sand particles are there. So, the type of material involvement, it also define what should be the name of this mass wasting. Then rate of movement, at what speed, at what velocity it is moving. So, if it is moving very fast, maybe it is avalanches, you might have seen in TV screen somewhere, sometimes there is avalanches, huge ice, huge snow, it is detached from the main ice body and is moving with huge speed. And sometimes the mass wasting, it is very slow. So, the rate of movement and the type of material, it is involved. So, classification of mass wasting, if this type of material is involved, either it is soil or debris or mud. Similarly, categorized by speed, that is slow mass wasting and fast mass wasting. Here the complete table giving this classification. You see the type of movement, what type of movement is there? Either it is a fall means it is a slope face, from the slope face a particular boulder is or particular cluster is falling down freely. So, only air resistance will be there, free fall, only air resistance, nothing else, no sliding friction, no frictional force with the body. So, that is called fall. Topple means like this, it is toppling down, it is also free fall, but one end it is attached to this main body, it is toppling down. Then slide means sliding, it is sliding down, this is the main intact body, main rock body, another the detached part, it is sliding down. So, slide there are two types, one is called rotational slide, another is called translational slide. Rotational slide, when you say the rotational slide, that means the detached part, it is performing a rotational motion. So, rotation means there should be a center around which it had to rotate. So, in that case this motion is on a curved path. For example, suppose we have a hill slope and hill slope is curved like this and this is the detached block. So, once this detached block has to move, it has to move this path this way. So, that is rotational slide, that means it is rotating here, it is rotating on this curved path. So, this is rotational slide. Another is called translational slide. Translation, simply it is sliding friction is there, slipping this detached path or this detached plane, it is a simply planar body and it is sliding down, translational slide. Then it is called lateral spread, that means the material which is detached from this main body, it is laterally spreading. Spreading means once the spreading is used, that means it is water is associated, it is spreading down. Then flow, flow means it is flowing, the detached material it is flowing, flowing water again associated. Then it is complex, complex means a huge body of detached mass, some part it is flowing down, some part it is sliding, some part it is in turbulent motion. So, like this submarine landslides. So, this is a complex one. Okay. So, mixture of all those things once we cannot define particularly, so we say it a complex one. Similarly, either it is rock is involved or soil is involved. If it is rock is involved or it is called bedrock in the engineering sense, it is called bedrock. If rock is involved, so depending upon the material associated, that can be classified as rock fall. That means rock is falling down from a slope face, a rock is falling down directly, that is called rock fall. Similarly, rock topple, rock body is toppling, rotational motion, it is toppling down, it is rock topple. Then rock slide, similarly rock is sliding down, rock spread, rock is along with water it is spreading. Then rock flow, again more water is associated. So, this type of classification is based on the rock involved. Similarly, if soil is involved, in terms of rock it is rock fall, in terms of soil is involved, suppose it is predominantly of coarse material. So, it is called debris. Debris means it is the weathered material irrespective of its size, it is debris. Debris it is consists of boulders to pebbles, cobble, salt, sand, silt, clay, every material, it is called debris. So, debris fall, the whole material is falling down. Then debris topple, same thing. Then debris slide, sliding of debris, debris spread, debris flow, all this case debris, the weathered rock material is involved. Then if it is fine material, then it is called earth fall, mostly soil, fine material, silt, clay, sand, these are associated. This is called earth fall. Then earth topple, earth slide, earth spread, earth flow. So, these are this classification based on this material involved and the type of movement it is associated. But combination of two or more is also possible. So, that means that does not mean only one type of material or one type of material is associated with one type of flow. If you analyze larger flows, even if smaller flow, if you vividly analyzing it, minutely observing it, then you can say many types of this classification is associated with one type of mass wasting too. So, that means, but the dominance part which is dominating, we name it like that. So, rock fall, that means major part of the rock is falling down, but within that rock fall there may be some grains they are toppling. What measure is looking at, that is takes the classification scheme. So, let us discuss it one by one. The first and foremost thing is creep, and it is the most simple one to understand. Creep is barely perceptible and non-accelerating down slope movement. If you see here in this photograph, here slope is downward and slope is very gentle like 1 degree or so. But if you see this rocks associated or exposed, here if you see here, concentrate here, this dip of this rock is towards this direction, but a dip is near about 80 degree or more than that. But once you are coming to the surface, here you see it is here, this was the dip, and here this much is deviating. Here the deviation is relatively less, here the relatively less, again less, and finally, this is the original dip of this rock body or the rock bed. So, once you see this rock from bottom to top, you are looking that the rock bed is bending towards the slope, and this type of movement of this rock bodies or this mass, whatever the slope mass, it is called creep. It is a very slow process. If I project this rock bed, it should expose somewhere here, but now you see this is shifted from here to here, this much distance has been shifted. So, this is called creep. It is the most common, in fact ever present in regolith on slope, but the term is also applied to the slow movement otherwise unweathered joint rocks also. So, whenever we say about creep, we always think that it should be associated with the weathered material with it, but not necessarily. Sometimes it has been observed that this joint intact rock mass which is unweathered, simply it is jointed but not weathered, that is also performing very slow motion down slope, that is also categorized under creep. The material moving down slope, which is called colluvium, the whole material it is moving downward. Suppose for example, we define this, beyond this there will be no movement, but once the weathering system goes down, once more time is involved, this movement may takes from here, again with more and more time the movement will take from here. So, that means depending upon the degree of weathering, depending upon the slope, what is the angle of slope, more angle the slope, less depth it is affected. If it is less slope, the effect will up to more depth. So, that means this material moving, the whole total material which is involved in the motion, that is called colluvium. Whether it is derived, either it is derived from in situ weathering or it is derived earlier weathered rock which is transported and deposited on the slope, irrespective of its origin, the whole material which is associated with the motion, this is called colluvium. If you see these two photographs here, the first one, you see these trees they are bending, all these trees they have bending roots. Similarly, here the fence it is bending, the tree roots it is bending. So, these type of signatures on the hill slope, that indicates the slope is under motion, and it is slow motion, perceptible motion, some millimeter to centimeter per year. So, this is due to creep action. So, this is divided into two parts, one is particle creep, another is soil creep. Particle creep, why it occurs? Individual surface pebbles or coals of soils are constantly shifting because of wetting, drying, heating, cooling, freezing and thawing. How it happens so? Now, you see, suppose this is the slope, we are measuring the creep motion. Here all these particles A, B, C, D, any particles, when it is expand, either the expansion is due to heating or due to freezing or due to absorb of water, anything. So, once it expand, it is expanding perpendicular to the slope, but during thawing process, during squeezing process, the particle is moving vertically downward. So, for a season or for a completion of one cycle, this particle once it was here, now it is shifting, it is shifting to here. So, this much is the horizontal distance the particle has moved. So, when the sediment expands, individual particles are lifted up at right angle to the slope. Sediments can expand when they are freezing, gets wet or they heated up in the sun. When the sediments are shrinking, the particles fall straight back to down. Creeps take a long time because each particle might only move a millimeter to centimeter per year. So, that is why from here to here motion, it will take some times, even if years or so. So, that is why each and every particle it is moving very slow process, and finally, this always nature wants to be intact. So, So, suppose we have a tree here, and this part is moving, but this part will try to remain intact at this point. That is why this tree will bend like this. So, this is due to creep motion. Soil creep is defined as imperceptible except over a period of years. Soil creep is more difficult to measure than particle creeps, because particle creeps, once we say, we consider is individual particles, individual rock particles, but soil it is a mixture. It is a mixture starting from clay particles to silt, sand or so. So, in that case it will be difficult to measure, because each particle would move in different rates. Soil, suppose for example clay part will expand very rapidly, similarly it will squeeze very rapidly, but if the sand is there, sand will not expand. Similarly, depending upon its size, the rate of swelling or the depth to which or the height up to which it will swell up, that also varies. So, that is why once it is a mixture of material is associated, it is difficult to assign a particular number. In that case, we have to average out, but if it is uniform, suppose for example, the slope is only composed of clay, that means it is uniform expansion or near uniform expansion and contraction. In that case, it will be easy to understand and assign a number. That is why particle creep is easy to measure and easy to understand, but soil creep, once it is a mixture of material, it is difficult to understand and it is complicated. Soil creep should be essentially laminar. It is very important here to note that once we say it is a soil creep, it is essentially laminar, with each layer of soil carried downhill by motion of the layers beneath it. The effect is cumulative, with the maximum rate at the surface and exponentially decreasing at the bottom. So, as we are talking something about few minutes back, if you consider here it is your undisturbed point. So, now you take this line and here you see this much has been deviated, here this much is the deviation, this much is the deviation, this much is the deviation. So, that means the motion is cumulative at the surface and gradually it is slow and it is going reducing with depth. So, that is why creep movement it is more at the surface of the slope as compared to if you move downward. So, that is why which are shallow depth material, those particles which are at the shallow depth or at near to the surface, they move more rate as compared to the particle which is lying below, and gradually the effect reduces down and at certain depth this becomes 0, and what depth it will be 0, that depends upon the slope, at what angle and what is the material we are involving. So, depending upon the material, depending upon this angle of slope, this depth varies. Then certain more information about the soil creep, usually on slope greater than 5 degree. So, that means 5 degree is the cutoff that it will be noticed, but that does not mean those slopes which are less than 5 degree, they do not experience creep. It is there, but to measure it, that means to measure it easily, this 5 degree is the cutoff. A rate of less than 1 centimeter per year can be caused by rain lubrication, by freeze and thaw, animal boring, expansion contraction. So, these are the reasons why the creeps occur, but it is starting from 1 degree to more than 1 degree or more than 5 degree slope. Then rock creep and topple. So far we are discussing about this soil creep, this material which is mostly of soil expanding and contracting. So, during expansion it is moving up perpendicular to the slope, and during contraction it is vertically falling down, and finally slowly the particle is moving down slope. Now, rock creep means here rock is involved, rock fragments are involved. Large joint bounded sheets or blocks slowly creep or lean outward the slope until they becomes unstable and topple over, slides down to the downhill. So, this is rock creep. That means large boulders are here. If you see here this figure, the photograph, here these are this weathered part, and here rocks are fragmented, classed, converted to different clasts. Those clasts try to move down slope, and unless they topple down. For example, if this is the free face of the slope, and if it is bending down, it is moving here and bending down, this side moving and bending down. So, ultimately this will detach this block, if you consider, it will ultimately detach from this main body and it will toppling down, free fall will be there. So, this is the creep. Here you see there are two dimensional motion. One is it is moving in the down slope, another side it is moving this side down slope. So, ultimately these fragments with time that will topple down from this main rock body, and this is this up to which when it is detached, when it is attached with the rock body, that is called creep. Once they free fall, they detached from this main body and topple down, that will be either categorized under fall or topple depending upon the motion. So, creep, the terminology only and only is restricted up to which it is attached with the slope, attached with the main rock body, then it is creep. Once it is falling down, that will be either it is fall or topple, that will be depending upon the type of motion involved. Most often rock creep is observed on a cliff face, where a massive rock such as sandstone overlies shell. If you see here this photograph, suppose we have a shell body here, and this is the bed of sandstone here, and this is the slope where it is exposed. So, we know shell, it is, though it is clastic, but mostly it is clay size particles. So, alternate expansion and contraction will be there. So, here once this sandstone is there, so here cracks are developed, and through cracks, if you see this, these blocks will tend to lean towards the slope. This is rock creep. So, here we will find soil creeps, the soils, mostly the soil which is moving down, but here wherever the sandstone is exposed, that will experience rock creep. So, rock creep and soil creep, but mind it, the creep movement here in the soil and the rate of movement here may not be same, because the material property is different, the slope is different. So, within a one slope also, if we have different type of material involved, the rate of movement will be different. Here that will be somewhat different rate, here somewhat different rate, and mostly when the rock creep, it is either if it is a sandstone body which is embedded within the shell, this part is very easily seen. The best documented history of the rock creep is here, the fall of threatening rock. It is national monument of New Mexico. It is a story behind it. For 5 years prior to fall, the gap between this cliff face and the freestanding rock monolith sandstone, it increased. So, the size of this rock monolith was 46 meter long, 30 meter high and 9 meter thick, and every month it was measured how it is detaching from this main rock mass. For 3 years, the gap widens at approximately 20 millimeter per year, and it was become a national monument in New Mexico. Rock creep illustrates the importance of pressure release joints are sitting parallel to the cliff face or gorge in the massive rock mass. Here some points has to be understood. The rock creep, they are everywhere present in the cliff faces. Either it is the pressure release joint. Pressure release joint means you might have heard about this plumose structure, tree like joints, joint planes which will tree like appearance, it is called plumose. Okay. So, plumose structure or plumose joints or sittings you can remember when there is pressure unloading, there are seats parallel to this open surface. If you see here, this is this cliff surface and this is the valley. This side is the valley and this is the cliff surface. And the cliff surface, once this side is open to the air, you will find sitting joints like this. Similarly, we have sitting joints like this, because this is the open space, this is open space. So, once pressure release is there, joints will be parallel to this surface, joint will be parallel to this surface. So, once this joint and this joint they interact, this block will be removed. Okay. So, this is sitting joint parallel to the cliff face and gorge wall, gorge when there is a river which is flowing here, very deep valley, this is called gorge. When open joints have formed, it is only a matter of time until weathering destroys the support and the large mass of the rock collapse from the cliff. Here, for example, few minutes back we are talking something about the rock of this threatening wall, here the fall of threatening rock. Here similar things, now you see this is the gap, it is annually it is increasing and finally this part is toppling down. Similarly, in this case you see this is the sitting joints, these are the sitting joints. So, with time it become attached from here, this part will fall down here, is not it. So, this will rock creep, that means slowly it is being detached from the main body and with time it is toppling down to this valley, it is rock creep. Rapid stream erosion can unbalance the stress distribution, so that this elastic expansion outward towards the valley axis, it is very important to understand. Here rapid stream erosion, mainly this occurs in hilly terrains like the Himalayas. If you move, there are many valleys, many rivers which are flowing through gorge. Gorge means very deep valley, and suppose there will be rapid rate of erosion. Rapid rate of erosion, either the river is rejuvenated or the whole system is uplifted. In the Himalayas, it is a tectonically active zone, active mountain belt. Here, once the system is uplifted, the river has to downcut its valley. Once river downcuts its valley, rapid rate of erosion occurs. So, more rock is exposed. For example, suppose the earlier this was this valley level and this much is expanded or it is uplifted. So, now river has to flow this level. So, this part is again exposed to the surface. So, earlier when this part was intact with this, so it was pressure balance was there, but once this part is exposed, so that means there will be free expansion towards valley. Similarly, there will be free expansion towards the valley. Once there will be free expansion towards the valley side, that means there will be joints developed, and those joints are the expansion joints, and through the expansion joints the rock creep starts. So, once the rock creep starts, this is the expansion and this is the free space. So, that means this block will try to lean down towards the valley slowly and slowly, and with time this part will totally topple to the valley floor. So, this is rock creep. It is one reason is the rapid rate of stream erosion. Then another type of mass movement, it is called flow. It is the incoherent rock debris may be mobilized sufficiently so that it flows like a viscous fluid. So, that means here water to certain extent is involved, it has to flow. The rock mass is to behave, or the rock debris has to behave as a viscous flow, viscous fluid. It is moving like this landslide. When there is cloud burst, there will be cloud burst in hilly terrains, the whole mass moves as flow, that is called rock flow. The criteria for defining flow are evidence of internal turbulence and either discrete boundaries of narrow margin zones of shear. So, here once the system is flowing, the whole system there will be internal turbulence in between them, and it is a narrow boundary which defines or demarcates from the main body to this flow mass. So, this line or this plane is define the zone of shear. So, shearing motion will be here, and here internal turbulence will be there, and with the help of water, with the help of gravity, the whole mixture it is coming down as a viscous fluid. This is called flow. Subdivisions of a flow can be based on either the kind of material involved, the degree of saturation, and the speed of advance. Flows typically move as lobes or tongues that follow the existing topography. So, when this material is involved and the speed, once the speed, the degree of saturation, the kind of material. So, either the material is totally of debris, or this totally of rocks, is totally of clays, and the degree of saturation, how much water is there. If water is less, the movement will be less. Similarly, if the slope is less, the movement will be less. The speed, if it is on sloping surface, highly sloping surface, this movement will be advanced, the movement will be very high. If it is slow, or this sloping surface is very less slope is there, so that means the movement will be less. So, depending upon this material involved, depending upon the degree of saturation, depending upon the degree or the speed of advance, this flow has been subdivided. One particular type of flow, it is called solifluction. Solifluction, if soil is saturated with water, the soggy mass may flow downhill in a few millimeters to few centimeters per day or per year. This type of movement is called solifluction. Solifluction, this term sol is from soil. So, that means here soil is involved. So, soil is involved, and if soil is saturated with water, it remains on a sloping surface, it will move as a lobe. For example, if you see here, this is one lobe, this is another lobe, this is another lobe, this is another lobe. So, that means once the system is moving downward with the help of gravity, with the influence of gravity, and it is water saturated, this type of lobes are generated, and this occurs, this essential criteria should be there, that the water is not released. Once water releases, that means water will be free from this material, and it moves out, this movement will stop, and or the movement will not stop, it will slow down. So, that means there should be a criteria, there should be a situation, there should be a condition in which water should not escape from the system, so that this movement will continue for long distance. Then another is called gelifluction. It is the solifluction with frozen ground, that is called gelifluction. So, solifluction and gelifluction, two different aspects, the same thing once it is on the frozen ground, that is called gelifluction. Solifluction is a form of mass wasting common whatever water cannot escape from the saturated surface, layers of soil percolation into the deeper level. This is solifluction. A clay hard plane is in a or an impermeable bedrock should be there, so that it will prevent water to percolate down. So, that means I want to say water should be within that system, so that it will accelerate the movement, it will continue the movement. In permafrost, mass of debris and soil may flow downward slope an almost negligible gradient, because melt water saturates the active layer, but cannot penetrate the frozen ground beneath. So, that is another reason. Once water is there within the system, the movement will continue. In frozen ground, generally the pore spaces, it is filled with ice. So, once its pore space is filled, it behaves as a impermeable member. Similarly, salt pan, hard pan, clay, if it is below and above is the soil, this water which is within the soil or the saturated soil, the water cannot penetrate down, cannot percolate down. So, that is why the water remains in the upper layer, and with the help of gravity the whole system moves downward. So, this is the essential condition for the movement, that the water should not percolate down. If water percolates down, then evapotranspiration occurs. So, that this mass which was moving with the saturation conditions with the water, that becomes 0. So, movement will stop there. So, this is the essential condition has to be well done. So, I think we should stop now, and we will meet in the next class. Thank you very much. Thank you for your attention.